Okay, so it's 3 o'clock. Let's come to the next session, the industrial session. So in this session, we will have three excellent talk. Okay, they're from Tencent, from Cisco, and from NVIDIA, Manox. All right. So our first speaker is Alan Lee. Alan is currently the chief architect of Tencent Cloud. Okay, and he's working on the cloud networking and data networking. All right. So today he will share us his experience about the scalable and flexible routing services for Tencent Cloud Access Network. All right. So let's welcome Alan. So please.
Okay, thank you. Can you hear me?
Yes, yes. Yeah, please go ahead.
Okay, thank you for the introduction. Hello, everyone. My name is Alan Lu, engineer at Tencent. I'm honored to be here to share some works with you. Today's topic is scalable and flexible routing service for Tencent Cloud Access Network.
Alan, sorry to interrupt for
Okay.
just a second. So I think during the talk, especially industry talk, there may be a lot of questions from audience. So for those, if you have question and you don't want to talk, you can type your question in the screen. All right. There is a chat button there. You type your question there. I can help you to ask the speaker. All right. So yeah, please go ahead.
Okay. Okay, this is today's agenda. First, I'm going to give a brief introduction of the Tencent Cloud Access Network, the scenario, the challenges we face, and explain why the traditional way cannot meet this challenge. Second, we will have a look at our new router architecture. And then I'm going to dive into the design details, take some use cases to see how we address these challenges with our new architecture. And last, I'd like to share some operational experiences and our future work. First, overview of Tencent Cloud infrastructure. Tencent Cloud International operates 54 availability zones spread across 27 regions globally. We have over 100 terabits per second public network bandwidth reserved and 15 exabytes for storage. And the scale is still growing rapidly. Tencent Cloud Access Network. This is what we will focus on today. With more and more customers deploying their services on Tencent Cloud, which are represented by the VPCs on the left of this diagram, how to efficiently interconnect customers' infrastructure with Tencent Cloud is becoming more and more critical for us. So first, we have provided a private LAN technology to allow direct connection between customers on-premise data centers and Tencent Cloud Access sites, that's providing high bandwidth, low latency network quality with high security. Okay, second, we have used the VPN technology to press these branches within their resource with low cost via internet. Third, for end users visiting these cloud services provided by cloud customers, we have built a large Tencent Internet Exchange infrastructure TICs in these access sites globally. And initially, we mainly relied on deploying traditional commodity routers in these access sites to meet various access requirements. However, as the cloud business grows rapidly recent years, more and more new challenges are emerging. And we found that the traditional way cannot continue to sustain anymore. So what's the challenges? The first is large scale forwarding table as well as the VRFs tunnels. For example, private LAN gateway requires up to 10K VRFs for a large number of tenants, and TIX requires up to 10 million forwarding table. Second, we had to roll out new network features fast to meet the various requirements from our business team, such as on-demand traffic engineering, interoperating with different kinds of networks and the services. Next, the capacity must be able to scale up easily to keep up with the fast growth of traffic volume. And meanwhile, we have to keep the cost at a low level to balance with the revenue. Okay, why the traditional router cannot meet this new challenge? Generally, the traditional router comprises 3 pieces of components. Processor acts as the control plane, running protocols like BGP, OSPF. LAN card acts as the forwarding plane with limited routing tables, echoes, and fixed forwarding behaviors. And switching fabric in the middle is responsible for high-speed internal interconnection. These components are usually tightly coupled. The processor capacity, routing table size, and bandwidth are usually configured with a fixed ratio. It's impossible to independently scale one dimension of them. And moreover, as the traditional router is always hardware, software vendor lock-in, a major change may take vendors several months or even more to design, implement, test, and release. And in short, the traditional router doesn't target cloud purpose. So it's hard to scale, lack of feature velocity, and expensive. So obviously, for cloud scale purpose,